Welcome to Lesson 7-7. That's Topic 7, Lesson 7. Today we're going to be working on the surface area of pyramids. So honestly, this is just like what we did with prisms, but it's with pyramids. So let's get on with it. We're going to start with finding the surface area of a square pyramid. And of course, pyramids have triangular faces, lateral faces that is, and one base, and they're named by their base. So if this is a square pyramid, well, then the base is a square. So Maxwell has this, house that he's made, this model, and he's got a pyramid for the roof, and he wants to paint the top of the house a different color. So anyway, he has a tube of craft paint that covers 20 square inches, and we want to know how many tubes he needs to cover the top of the model. And we're going to include the base of the pyramid in our calculations. So that's kind of important to know, even though it might not all show. We're going to paint the entire bottom. Well, let's make a net. We'll start with the base, and the base is a square. I know that because that's what they told me. And then folding down from each side of my base is a triangle that forms a lateral face. So I'm going to unfold all four of those. And so there we are. And if I go and label this, I know that this square is 3 inches by 3 inches. And I didn't do this to scale very well, but that is 5 inches. And so I have two shapes. I have my square, and I have my 4 lateral faces. Moving that over to the side, I have area of shape A. It's a square, so I can do side squared. I'd just like to do base times height, which is 3 times 3, which is 9 inches squared. Then the area of shape B, that's a triangle. That's 1/2 base times height, because that's 1/2 of a parallelogram. It is 3 inches at the base, 5 inches for my height, times 1/2. So that's 1/2 of 15 is 7 5/10 inches squared. And so my area total is area of shape A, and then 4 groups of shape B, just like that, and like that, and like that. And I get 39 inches squared. That's how much paint I need, and each tube is 20 square inches. So it looks like from my bar model here that I'm going to need 2 tubes. That's what's needed. And that would give me 40 square inches of coverage, and so I'd have a little bit of paint left over. Here's another square pyramid for you to find the surface area of it. Draw the net. All right, start with your base and then fold your triangle sides down, and give it a try. We'll talk about it in class. All right, we could also have a triangular pyramid. Remember, pyramids have lateral faces that are triangles. They're named by their base. Since this is a triangular pyramid, this base must be a triangle. And look at the picture. It is. Now, as I read the problem, it said Tamara made a small gift box that's the shape of a triangular pyramid. How cool. The faces of the box are identical equilateral triangles. Equilateral, equal sides. All right, and then how many square centimeters of cardboard did she use? So I'm going to draw a net. Here's my base. It's an equilateral triangle. And then I'm going to do my lateral faces. They're also equilateral triangles. I'm going to draw those by hand. It's not perfect, but it'll do. It says that the height of these is 4 33/100, and the base is 5. And they're all the same. They're all the same, it says here. So I only have one shape, shape A, and there's 4 of them. So the area of shape A is 1/2 base times height is 1/2 5 times 4 33/100. And in the end, I'm going to have 4 of those. So let's see. I'm going to just take this whole thing and times it by 4. Now when I do that, some interesting things happen. Let's break that down and see why I'm doing this. All right, I put the 5/1, and I put the 4 and 3300s over 1, and I put the 4 over 1. And let's do some cross canceling. This 2 cancels here. Divide by 2. Divide by 2. Now look. 1 times 1 times 1 times 1 on the bottom is just 1. 1 times 5 is 5. I'm going to just skip over and multiply that by 2. So that's 1 times 5 times 2. That's 10. 10's easy to multiply by. All I have to do is move my decimal over one place, and I get 43 and 3/10 centimeters squared. Now that's not saying you needed to do it that way. You could have just found the area of one triangle and then multiplied that whole thing by 4. But by doing this, seeing this little trick here, I was able to save myself some work. And here's some straight up practice. We have another triangular pyramid, and it says here that the faces are equilateral triangles, and all the faces, the base and the lateral faces, all those are identical to each other. So go ahead and calculate the surface area of that pyramid, and we'll go over it in class. Take care.